Hey guys, here we are for lesson 3 in unit 2. Today we are talking about more constant proportionality. So we're going to sort of continue off where we left off yesterday. So 3.1 in our books, which you should all have, we are going to be on page 21. Okay? So, 3.1, equal measures. Use the numbers and units from the list to find as many equivalent measures as you can. For example, you might write 30 minutes is a half an hour. So, go ahead and hit pause and write down as many as you can, and then when you get done, hit play, and we'll get back going to it. All right, so hopefully you've come up with some. Here are some that I can think of right off the bat. Let's see, let me get my old pencil ready here. 60 minutes is equal to 1 hour. Okay. 24 inches. 24 inches is equal to 2 feet. Okay. 6 inches is equal to a half a foot. Okay. 12 inches is equal to a foot. Okay, so there's lots on here. Hopefully you came up with some, and we'll move on. So we'll turn the page to 22. Centimeters and millimeters. There's a proportional relationship between any length measured in centimeters and the same length measured in millimeters. So we have a little ruler here, and it has centimeters on the top and millimeters on the bottom. And if you look here, the centimeters match up with the millimeters. So 1 centimeter is 10 millimeters, 2 centimeters is 20, 3 is 30, 4 is 40, 5 is 50, and so forth. So there are two kinds of thinking about this proportional relationship. If you know the length of something in centimeters, you can calculate its length in millimeters. Complete the table. What's the constant proportionality? So I'm going to start with B. What's the constant proportionality? Whoops, one thing here. Let's turn on the old pen. What's the constant proportionality? So I know that 1 centimeter is 10 millimeters. Okay? Let me move this up a little. So remember, constant proportionality is second column divided by first column. We talked about this yesterday. So this is the first column, everything below it. This is the second column, everything below it. Okay, so second column, 10 over 1. Well, if we go 10 over 1, we simplify that, it's just 10. So my constant proportionality is 10. So I'm just going to multiply everything in this first column by 10. So I'm just going to multiply by 10. So 9 times 10, 90. 12.5 times 10, 125. We just have to move the decimal over. 50 times 10, add a 0, 500. 88.49 times 10, 884.9. Okay, what's the constant proportionality? Figured that out, it was 10. Now, number 2 says if you know the length of something in millimeters, you can also calculate the length in centimeters. Complete the table. So now we're going backwards. They give us the millimeters and we need to find the centimeters. So we know that 10 millimeters is equal to 1 centimeter. So my constant proportionality is 1 over 10. So I'm going to multiply everything by 1/10 here. And then multiplying by 1/10. So my constant proportionality is 1/10. So multiplying by 1/10 is the same as dividing everything by 10. So 70 divided by 10 is 7. 245 divided by 10, we just have to move the decimal over once, 24.5. 4 divided by 10 is 0.4. Move it over once. And then 699.91, if we move it over once, 69.91. Okay? So how are these two constant proportionalities related to each other? Well, if we look here, this is on the bottom of page 22, number 3. So if I move this up For some reason that doesn't want to move up. So I'll just erase it real fast. Bye-bye, 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 bye. And we're good. All right. So how are these two constant proportionalities related to each other? So the first constant proportionality was 10. The second one was 1 over 10. Well, if we turn 10 into a fraction, 10 over 1 and 1 over 10, they are reciprocals or inverses of each other. Okay, so if we take the columns, if you notice up here in the columns, all they did is they flipped centimeters and millimeters. So first centimeters was to millimeters, and then second millimeters was to centimeters. So they just flipped them. So we can do the same thing with the constant proportionality. If we take the table and we switch columns, we just have to flip or take the inverse or reciprocal of the constant proportionality. So to convert from centimeters, number 4 at the top of page 23, to convert from centimeters to millimeters, you can multiply by 10. To convert from millimeters to centimeters, you can divide by 10 or multiply by 1/10. Okay? Moving on. 3.3, Pittsburgh to Phoenix, the bottom of page 23. A plane traveling at a constant speed flew over Pittsburgh, St. Louis, Albuquerque, and Phoenix on its way from New York to San Diego. Complete the table as you answer the questions. Be prepared to explain your reasoning. Okay. It says, what is the distance between St. Louis and Albuquerque? Okay. So we need to find this thing right here. If you think back to Unit 1, we talked about this in one of the lessons, and it's the distance formula. Distance equals rate times time, and rate is your speed, how fast you're going. Okay, so let's figure out the speed. So from Pittsburgh to St. Louis, they went 550 miles in 1 hour. So how fast were they going? Well, they were going 550 miles per hour, and that is the same for all of them. Okay, so if we know they're going 550 miles per hour there, and we know the time, 1 hour and 42 minutes, we can figure out the distance. We can take these two, we can take and plug that in for time, and we can take speed and plug that in for rate and multiply them together to figure out the distance. What I have to do first, though, is I have 1 hour and 42 minutes. I have to convert that into the same unit of measurement. Okay? Now my rate or my time is always done in hours, so I'm going to turn 42 minutes into an hour. So if you think 42, there are 60 minutes in an hour. So to figure out how much of an hour 42 minutes is, I'm just going to divide the two. So if I go 42 divided by 60, I get 0.7. So this really is 1.7 hours. So all I'm going to do to figure out the distance between St. Louis and Albuquerque is I'm going to go 1.7, that's a 7, times 550 miles an hour. So using my calculator, 1.7 times 550, I get 935. So 935 miles. Got a lot of different colors going on here. Now, Albuquerque to Phoenix. It says, how many minutes did it take to fly between Albuquerque and Phoenix? So it says minutes, but if you notice, our speed is an hour. So once again, we're going to have to convert. So we know we're going 550 miles an hour. Okay? So I know the distance, it's 330. I know the speed, it's here. So I need to, let me move this a little bit so I have somewhere to write. Right over here. All right. So I know the distance equals rate times time. Well, I want to get time all by itself. So if you think back to 6th grade, to get rid of multiplication in an equation, we divide by the rate. So the r's are going to cancel out. So time just equals my distance divided by my rate, or my speed. So I know my speed is, I know my distance is 330, and I know my speed or my rate is 550. So I'm just going to divide those two. 330 divided by 550 equals 0.6. Okay, so that's 0.6 of an hour, though. We have to convert it into minutes right here on number 2. Okay, so there's 60 minutes in an hour, so we just go 0.6 times 60, and we get 36 minutes. Okay? What is the proportional relationship represented by this table? The proportional relationship is the number that doesn't change in the column. So the only number that is the same on each row is this right here, 550 miles. So the proportional relationship is your speed, 550. Diego says the constant proportionality is 550. Andre says the constant proportionality is 9 1/6. Do you agree with either of them? Explain your reasoning. Well, they are both right. Okay? Diego uses miles per hour, and Andre converts 550 miles per hour into miles per minute. So 550 divided by 60 minutes is 9 1/6. So that's where he gets the 9 1/6. He just turns it into miles per minute, not miles per hour. So they're both right. They just use different rates or different speed. Different rates. One used minutes, one used hours. Okay? And that's it for the lesson. So let's look at the summary. When something is traveling at a constant speed, there is a proportional relationship between the time it takes and the distance traveled. The table shows the distance traveled is the elapsed time for a bug crawling on a sidewalk. Okay? So it has all of these, and then if you notice down at the bottom here, they have the constant proportionality. So 3/2 times 2/3 is 1. 1 times 2/3 is 2/3. 3 times 2/3 is 2. And 10 times 2/3 is 20/3. So we can multiply any number in the first column by 2/3 to get the number in the second column. We can say that the elapsed time is proportional to the distance traveled, and the constant proportionality is 2/3. This means that the bug's pace is 2/3 seconds per centimeter. Okay? This table represents the same situation except the columns are switched. Okay? So if the constant proportionality is 2/3 and they switch the columns, constant proportionality is also going to get switched. So 2/3 now is switched to 3/2, 3/2. We can multiply any number in the first column by 3/2 to get the corresponding number in the second column. We can say that the distance traveled is proportional to the elapsed time, and the constant proportionality is 3/2. This means that the bug's speed is 3/2 centimeters per every second. Notice that 3/2 is the reciprocal or inverse of 2/3. When two quantities are in proportional relationship, there are two constants of proportionalities, and they are always reciprocals of each other. When we represent a proportional relationship with a table, we say the quantity in the second column is proportional to the quantity in the first column, and the corresponding constant proportionality is the number we multiply values in the first column to get the second. Okay? So there you have it. With the assignment, there are 2 questions. Question number 1 deals with, you're going to fill out a table. So remember, you need to find the constant proportionality first by going second column divided by first column, and then multiply all the numbers in the first column by that number. Okay, and then they take it and they switch the 2 columns. So the constant proportionality is also going to get switched. Okay, and then question 2 deals with question 1 and the constant proportionalities of which we're comparing inches to feet. So there are 12 inches in a foot. Inches comes first, feet comes second. So there you have it. If you have any questions, let me know. Go ahead and send me an email, and I'll get back to you and help you.